Good evening, folks, and welcome. I'm Luke Erickson, Public Programs Associate, and I am here to introduce the acclaimed physicist Dr. Charles Falco. Dr. Falco holds a named professorship at the University of Arizona, where he has been a professor of optical sciences since 1992. He received his PhD in experimental condensed it's a mouthful here. It's not stuff I'm used to talking about science rather than art, but Condensed Matter Physics in 1974 from the University of California, Irvine, after which he joined the Argonne National Laboratory. Falco has served on numerous scientific panels, advisory boards, and review committees for various government agencies and universities, and also the editorial boards of 2 journals, and is a member of organizing, programming, and advising committees on over 20 international conferences and workshops. He is also a fellow of the American Physical Society, the Institute of Electrical and Electronics Engineers, and the Optical Society of America. Falco's principal research interests are the growth structure and studies of the physical properties of metallic superlattices and ultra-thin films, including research on magnetism, superconductivity, X-ray optics, elastic properties, and the nucleation of epitaxy of the thin films, as well as computerized image analysis. He has authored or co-authored over 250 papers, 6 book chapters, and many chapters of books, and has talked in university and conferences all over the world. Okay. In addition to his scientific research, Charles Falco has served as the co-curator for the blockbuster exhibition, The Art of the Motorcycle, at the Guggenheim Museum, and has also been collaborating with the artist David Hockney to discover scientific evidence that demonstrates that lenses have been employed by many artists as optical aids as early as the onset of the Renaissance. For this latter work, he was given the National Art Education Association's 2008 Ziegfeld Lecture, awarded for his role in developing the Hockney-Falco thesis, and it is for its relevance to the field of art education. It is on that very topic tonight that he will talk about the Hockney-Falco thesis, and without further ado, please welcome Dr. Charles Falco.
Thank you very much. So, how many of you are here for the NAEA conference? Some. So, I assume that there would be some of you. So, I'm giving a plenary lecture on Saturday there that is going to be 90% different than tonight. So you don't get to hear the same thing twice. And on the subject of condensed matter physics, I'm reminded that at one of the events for the Guggenheim, when we organized the Art of the Motorcycle, my co-curator was introducing me to somebody else in the art world, and said, Falco holds the chair of condensed matter physics. And she looked at me with this most just puzzled look and said, "What's condensed metaphysics?" And so I wish I had the chair of condensed metaphysics, because it'd be way better than the condensed matter physics. So you can bring down the lights, and we're going to get started tonight. If this works. Uh-oh. So we have a computer issue, which I'm just going to tell you, it's going to cause me heartburn tonight. And it's Apple's fault. Apple, when you install software, has got one really bad acting piece of software when it goes with the IBM PC, and it just like a zombie, you can't kill it. It keeps coming back, and it interferes with my remote. I'm going to talk about the tyranny of the lens, and I'm going to tell you what that means. I will give you some acknowledgments as we go through. David Graves and Richard Smith are David Hockney's assistants in studios in Los Angeles and London. Martin Kemp, an art historian at Oxford, helped David early on. Jose Sassian did a particular ray tracing calculation that I'm not going to show you tonight very early on that saved me all sorts of effort. And I'll tell you about the others. Alton Guilfoyle was my co-curator of the Art of the Motorcycle, and I'll tell you about that in a moment. Now, if you want, I'm going to assume in some sense that I've already proven to you that lenses were used by early Renaissance artists. I'm going to show you results based on that. If you want to see the proof, I mean, that's a whole talk in itself, sort of the talk I'm going to give at the NAEA on Saturday. If you want to download papers and read about that, I have a web page. It's impossible for you to remember the URL. So at no small expense, I purchased the domain name art-optics.com. And for the dyslexic in the crowd, I also purchased optics-art.com. And so right now it's currently linked, and if you click on that, it takes you to my University of Arizona webpage without you having to remember the whole URL. And so hopefully you'll remember hyphen, since it's such an odd word. So I'm going to give you a general introduction to what this is all about and tell you why I call this the tyranny of the lens. Then we're going to talk about some optical consequences. I'm going to show you what the Hockney-Falco thesis is, that these artists used optics, and tell you about that in the introduction. And then I'll show you consequences of it that will change the way you look at paintings. And so when you go back up through the galleries, you're going to look at paintings differently, knowing the information that I'm going to tell you, and give various examples of that. And then I'm going to give you some examples of post-optical imaging. In fact, I went through the galleries here earlier today, and sort of based on some paintings I saw, I changed my talk almost entirely from what I was going to talk about. I used different examples so that those of you who are from Minneapolis who've got a chance to go back through the galleries can look for specific examples that show you what I'm talking about. And examples from Monet, Derain, Pissarro, I think one other, I don't remember if I put that in, and then summarize. So as an introduction to all of this, perfectly fine painting, nothing wrong with it. It's in the National Portrait Gallery in London, but it's completely wrong in one sense. This is not how we would have seen the scene. If this was a real scene, we wouldn't have seen this gentleman in focus and the building out of focus. The human eye does not see simultaneously the same scene, partly in focus, partly out of focus. You look here, you focus on this gentleman. You look back there, you focus on the building, your eye. The muscles in your eye contract to refocus further in, and your mind builds up the entire scene, always in focus. So, look perfectly fine to us. And the reason why it looked perfectly fine to us is we've been indoctrinated for the last 150 years or so to think that lenses give us a good representation of vision. This is the first photograph, chemically fixed projected image, 1839, and what I'm going to show you are a bunch of images that are going to go by. They're in a third of a second each. And so you're not going to have time to articulate, even to your own mind, what the image is, but you're going to recognize every one of them. So the fact that we recognize images so quickly, because we've had as primates 30 million years of evolution as a primate to evolve our brain, a third of our cortex, or a third of our brain is the visual cortex. So we have great imaging skills, but since 1839, we've been led to believe that the lens reproduces how we see. And I'm going to show you that's not how we see at all. So we've all been sort of brainwashed by the billions of images that we've seen. So we come to a painter, Philip Pearlstein, paints this painting. He argues, he says, I never use mechanical or optical devices. And I believe him directly. It's not like he's tracing a photograph. Another book, cropping is never planned. It results from the struggle to find the proper scale and forms. Well, the fact is that what Philip didn't realize when he said those things is he was a photo editor for Life magazine in the early 50s. He sees the world through the viewfinder of a single lens reflex camera. So he doesn't have to actually use the lens to project an image to trace it to be using optics. He's been indoctrinated to believe he's not using optics when in fact, quite obviously, he is using optics. That's a former assistant of mine. I just set up a ladder and it's the same scene through a single lens reflex camera. So to step back a little bit, so David Hockney, for those of you who wandered in from maybe the science world, posterity may well acclaim him the greatest of modern portraitists. So he has very highly developed visual skills. And
David Hockney, our most celebrated living artist.
He is considered to be one of Britain's greatest contemporary artists.
His originality and skill have ensured his success from the beginning of his career.
So you're in the art world. You're in an art museum in the evening, so you probably know these things. Many scientists, many people in the general public don't know this. But one thing about David that you may not know.
I mean, I admit, for instance, I am interested in pictures. I keep saying this. I'm interested in how you make pictures.
For his entire career, if you read his books he's written, listen to television interviews he's given for 30 years, 40 years, that he's been driven by wanting to know how certain paintings were made. How were the images created? And this quest, a scientific quest, to understand that, it led us to what we've, some of the information I'm going to share with you tonight. So this article appeared, the January 2000 New Yorker magazine. My co-curator called me, said, Falco, drop whatever you're doing, read this article and call me back. And this started the most intensive period of collaboration of my entire scientific career. And ironically, although I work in condensed metaphysics, I have a scientific thesis named after me in something that I just did as completely off the track of my scientific career. What's important to this is that this quote, we dissected the workings of paintings that deceived so many experts in visual composition. Every painting that I show in a different version of this lecture, every painting, every bit of scientific evidence comes from paintings from the Hermitage, the Prado, the Louvre, from museums that if you believe their attendance figures, there's reasons not to believe them. I'm sure this museum's different. But if you believe their attendance figures, 25 million people a year go to those museums. 25 million people a year after year, go to those museums, see the same paintings that David Hockney and I saw, and we extracted information directly from the images themselves that nobody had seen before, nobody had noticed before, or nobody had realized the significance of before. If you asked a bunch of scholars, would you agree with the following statements? That optical instruments first appeared late in the Renaissance, when Galileo invented the telescope. Well, someone who was really an expert would say, well, you know, Galileo was a great salesman. He took credit for having invented the telescope. In fact, it was invented a couple years earlier, and he stole the idea, but we won't argue with the date 1600. Mirrors only reflect images. If you want to focus an image, it requires a lens. Hard to argue with that. And Renaissance masters, the Van Eycks, the Caravaggios, Bellinis, worked by sheer genius alone. Well, in fact, our discoveries show that all of these statements are wrong. Not wrong on technicalities, but fundamentally wrong. If we look at mankind's attempts to represent the human form, the three-dimensional human form in 2 dimensions, well, we go back 4,000 years, we see several things. First, we see that this person can paint better than I can. We come forward, still it's flat, it's more ornate, but flat, not very three-dimensional. But we come to Van Eyck. If I magnify it to this size, if this is Van Eyck, if this is this gentleman walking in the room right now, we would all recognize him. How did Van Eyck do that? How did he suddenly make this transformation from paintings that looked flat, not very realistic, to photographic-like in quality? Well, there's a strong clue right in the painting itself. Every feature that we've shown is based on optics could have been done with a pair of reading spectacles. If you go to the drugstore, you see a rack selling cheap plastic spectacles. In fact, if you break yours and you go there, they're not so cheap. They're 20 bucks. They should be, and they scratch easily. They're numbered, 1, 1.5, 2, sort of the average age of this audience. Everybody in here uses 2s. That's 2 diopter, which 2 diopter, it's a scientific unit of measurement. It turns out to be 50 centimeter focal length. And everything that we've done to within the accuracy we can calculate a focal length of a lens that was used, it's about 50 centimeters. So everything could have been done with that pair of spectacles. And so the evidence that Van Eyck knew about this, well, at least he had the spectacles. We have circumstantial evidence, though, that concave mirrors were used, and I'm not going to go into that tonight. And just to show you, my laboratory is on the 10th floor of a building. There's a pair of cheap reading spectacles. The assistants, we're seeing the direct reflection from the front surface of it, but we're seeing now the projected image. And a feature of every projected image is it's upside down. The sky is below, rooftops. The earth is above. And you can project. And this right there, you drew lines, is everything you need to do to develop the laws of geometrical perspective. If we look at attempts to represent geometrical objects in perspective, well, we come to about the same time, but you don't need me to fit a perfect perspective-corrected hexagon to that to see that the hexagonal table isn't quite right. Again, we come to our friend Jan van Eyck. The chandelier and the Arnolfini marriage, I'll magnify it. Now, what I want you to appreciate is that that chandelier on the actual painting in the National Gallery, if you take your cupped hand and cover it, you can cover the entire chandelier. It's this big, the size of my cupped hand, and I've blown it up to be 10 or 15 feet across, and it's maintained its amazing fidelity. How did Van Eyck do that? We have a length scale here from the size of the candles and the like. What I'm going to do now is I'm going to fit to this a perfect computer-generated, idealized hexagonal chandelier and see how well it fits. Well, at first glance, it looks like it fits extremely well. At second glance, you see, well, there's some deviations. The deviations is a couple of millimeters. Van Eyck has made something that has hexagonal symmetry, arms that are forward, sideways, backwards. Other information I'm not going to show you tonight. I calculate that the chandelier is roughly 1 meter across, weighs about 40 pounds. Huge chandelier, ornate chandelier, handmade in Flanders in the 15th century. If we had found that this fit perfectly, we would have assumed that Van Eyck had understood the laws of geometrical perspective, which had not been developed yet. You can draw something in perfect perspective. He didn't draw something in perfect perspective. He drew something as well as a handmade object could have been made in the first place. So the deviations, in a sense, are clues that optics were used, and they're much more quantitative information. As I said, art-optics.com, you can download the papers with all the calculations in it. I'm going to take it as a given that I've already shown you that so that I can show you new information. And so, as examples, what our results have shown is, for example, the chandelier is based on an optical projection. The Hans Holbein anamorphic skull, optical projection. The little dog, not. Paintings are more complex. Don't think of paintings, don't think of the information I'm giving you as saying that paintings are essentially photographs fixed by paint instead of by a photographic emulsion. They're collages, they're composites. They can include several different features, each of which was independently projected, and other features that, like the dog, the shoes, could have been, the shoes may never have even existed in real life. They could have been totally a figment of Van Eyck's imagination. The dog he could have done strictly from life. So they're much more complicated images.
Here's what's so revolutionary about what you're saying. You're saying the history of art, the history of the Renaissance, is the history of optics.
I am saying
I know that, and you're blowing everything up. You're blowing everything that all of us who took art appreciation studied, all the art historians have written, and you're saying you're all wrong. It's all about optics.
That hasn't made us popular with art historians. So if we're saying that artists first started using optics circa 1425, when did they stop? Well, I'll answer that. I'm going to give you a complete visual history of optics-based paintings. Every painting I'm going to show you has elements within it that are based on optical projections. And we're going to start in 1425, and we're going to come up to present in 18 seconds. So if you blink, you're going to miss a century of paintings. But every painting you're going to see has a feature in it, and they're in chronological order, and they're by name brand artists, by the Caravaggios, Bellinis, Ingres of the world. And here we go. And you'll see, these are paintings, you recognize them all. These are the iconic images of Western art. And we've shown each of them contains features that are based on optical projections. So the answer to the question, when did they stop using optics? They never stopped. It's been a continuum throughout art history from approximately 1425. This changes how you walk through a museum like this, because you're looking at paintings that are either directly based on optical projections, or the artist was aware of what optical projections did and has reproduced effects that are similar to optical projections. But there's a problem with optical projections. They give you the point of view of a paralyzed cyclops. So that's not a good thing. I mean, a lens solves certain problems, but a lens then, the tyranny of the lens is because it solves so many problems, a lot of people have been sucked in and then use it where they don't need to. And it affects how artwork is represented. This is one of the first paintings David did after we started collaborating. We started discovering our evidence. And it's the view from his studio in Hollywood. His studio is built on a former tennis court. So that gives you the scale of it. And as you're walking out of the door, there's the gate to leave the compound. There's his house. And so this kind of looms large in your eye because at this point, typically, you'd be ready to leave and go off. I stood in that same place, and with a semi-wide angle lens, a 35 millimeter focal length lens on a 35 millimeter camera, I took a view of that scene. And the same area covered by David's painting takes 6 overlapping views of a semi-wide angle lens to reproduce that. And I would even argue, and I don't know how to do this experiment, if you took 100 people to David's studio today, walked around, they left, and then 10 years from now, you showed 50 of them that painting and 50 of them the composite and said, where was this? I suspect more people would say, oh, I remember, that was David Hockney's house. From that, than from the arguably much higher resolution photograph, because he ties into how humans see, which is not photographically. The widest angle lens on a 35 millimeter single lens reflex is 14 millimeters. It's actually a fairly narrow point of view. That we see things over a much wider point of view. So there's a 14 millimeter view. We see things over a much wider area than that. And because the way we see is in high resolution, we look around and we have a very small area of our eye that picks up things in high resolution, and it grabs it all, puts it in our brain, and our brain gets the final composite. So in the end, this is what I'm seeing right now. I mean, I see the entire audience, which is much wider view than a wide-angle lens would have, but I see people from all different sides, a little blurry or off to the side because I haven't looked there very much. And I may remember the mountains outside my house as bigger, so I could represent them as bigger in my mind. I mean, so to show you how deceptive a lens is, there's the angle of view of this 14 millimeter lens, parallel lines. The only way you can have parallel lines stay parallel is if you distort the scene greatly with the lens. The light from the edges here has to travel 60% further to reach the edges. So the magnification of the edge is 60% reduced by 60%. So the only way we get what we think is good, accurate photographic representation is because the lens lies to us by so much to make parallel lines parallel. This is a segmented linear perspective. This is as if I look straight ahead, I look over here, I look there, I look there. And this is much more, it's still not a perfectly accurate representation of human vision, but it's a more accurate representation of human vision than a photograph gives. And in fact, unfortunately, I couldn't find an example here in this museum to show you this. You can find a number of paintings from the pre-optical period where the paintings much more represent how we see things before the lens stepped in.
This was the last of the big photo pieces I ever did. It was by far the most complicated. I just simply learned an enormous amount doing it, discovered an enormous amount, and it's simply in my head now, that understanding.
Well, thanks to my collaboration with David over the last 10 years, some of that understanding is in my head now. I mean, one of the nice things about collaborating with somebody like David Hockney is you learn a lot. I mean, one time I visited him, and he was getting into watercolors again at that point. And I said, well, David, you know, everything I know about watercolors I learned in kindergarten. And he spent the next hour teaching me about watercolors, how to mix them. I thought, if I were an art student, what would I pay for David Hockney to spend an hour teaching me about watercolors? And he's just wasting it on me because, no, I can't paint. But what he taught me about how paintings are made helps understand mistakes that are in paintings, understand a lot of the evidence that we're able to extract. I'm going to show you one example of optical evidence that optics was used. By Velázquez, Portrait of a Young Man. This is Portrait of a Young Man, the size of it and the like. If you turn that painting sideways and take an infrared reflectogram, infrared light in many cases penetrates further into a pigment than visible light and allows you to see, in many cases, but not all, if there was something underneath the surface paint. And in fact, there is. There's this. So there was the original image. That's all you can see in the visible. But in the infrared, we see this guy. It was on the canvas. He's painted over it. Well, it looks a lot like that guy. In fact, it is that guy. So this is a figure from a different Velázquez painting, but it's a mirror image of a painting. That in the painting itself, if we flip it by 180 degrees, as a lens does, flips things right to left. And I put it back in. This is the mirror image in the infrared reflectogram, and it's at a different size. It's 48% size. You use a lens to project something at a different magnification to a different size, and it flips the parity of the image. A lens was used by Velázquez. Other consequences. Now, these don't prove optics were used, but there are consequences that once you understand that these artists, starting in 1425, and all the major artists were using optics in portions of their paintings. I can show you, stop for a second, I can show you a Bellini painting where it clearly didn't use optics, a Bellini painting later in time where he clearly did use optics, and a Bellini painting later still where he didn't. They used optics where it was useful to them. They didn't use it where it wasn't useful to them. It was a tool. And a consequence of this, what's wrong with many of these things, are the evidence are analyzed in the sense of what's wrong with this picture. You look at them and you say, what's wrong with it? Well, what's wrong with this is, well, your mouth is symmetric, and I can show you how this mistake was made. Hans Holbein had a little portrait studio set up at Windsor Castle for a long time, painted a lot of the royalty, and all the scenes, they're all the same size, all done the same way, as if he had a camera obscura projecting things. And when you do this projection, one of the easy things to make a mistake with is, here's Richard Smith, David's assistant. So 2 pictures of Richard. They look like, I mean, if you just glanced at them, you say, well, they're about the same. Let me fade these out. And I'm going to take the top half of this picture and the bottom half of that picture, and I'll combine them, and we have that same problem. So what happens if you have somebody in a camera obscura and you're tracing, you look up, looking back and forth, if you tell the person to sit still, and they just sit pretty still, it's just so between one point and the next, they move their head by a degree or so. That's all it takes for you to make that kind of mistake. And so we can see from the same series, we can see ones that are done correctly. We can see ones, in spite of this defect, I'm in love with this woman. I don't know what it is. I've been in love with her since I first saw her, and I'm willing to overlook her defect. Albrecht Dürer, her mouth is off. Let's move the mouth over, and we can have it correct. What's wrong with this picture? Anybody? Well, not only is the arm too long, the elbow's in completely the wrong place. And I'll show you how optics can do that for you. So let me expand. I'll take this little region of the door frame, which should be a straight line, and I'm going to take that whole region, I'm going to expand them horizontally. Here's the door frame. There are jags in it. There's the jag right at the same height where the elbow is messed up. If he based this on a projection, it turns out you can't project a large image, a large scale image that's half a meter tall or so. You can't project all of that with a simple lens. It gets too blurry at the edges. You have to project the head, the shoulders, and move your lens down. And so let's paint this as he would have had to have done this if he'd used a lens. Well, we project the top half, then we slide our lens down and we match things up. And we continue. And we piece it together. And we fill in the color, fill in all these other details maybe by eyeball, and we fill in the color, and that's how we can make that kind of mistake. It's a consequence. This doesn't prove he used a lens, so don't think I'm saying that I'm using this to prove. I'm saying that it explains all the features of this. Here's short, dumpy Professor Falco. Here's tall, handsome Professor Falco. Taller is better. What's wrong with this woman? Well, she's got Arnold Schwarzenegger's arm. So here I've just taken this arm and I've cloned on that size. It should be more like that size. Again, something that lenses can do for you, because when you do the optical setup, the next time you go in, you change the magnification by a little bit, and you make that mistake. Other consequences. If we look at scale, and I'll show you some examples of optical scale. Who's closer to us, the boy or the girl? The girl's clearly closer to us. She's not. Girls should be like smaller. So when you piece together a scene, because your lens doesn't allow you to capture the entire scene all at once, you have to kind of bring people in. You stand people, say stand here, and you project them. A lens can make that mistake. He's just like too big. He should be more like that. And they're, actually now I realize, I bet there's an example here of the way I saw today. I went through the museum too quickly. Okay? How old is the child? Just, what does the child look like? 5. Okay, so you're sitting down. There's a 5-year-old standing in front of you. Put your hand at the height of the 5-year-old's top of his head. Well, that woman's got to be like 11 feet tall then. So, again, we can see examples of the mistakes you make if you use a lens. If you're drawn too close to the subject and you're not thinking about what you're doing, and the lens can do that for you. If you're projecting the image, it almost forces you to get too close to it and make mistakes like this. Her head, little pinhead. Her head should be bigger. Well, these guys are cheating, but they're like a really horrible job cheating. He's looking at his cards. He's trying to figure out what cards he's got by reading the lice on his head. And he's just looking off, I don't know, for something else. So if Caravaggio posed each of these separately, and I'm not showing you, I've got evidence in one of his paintings that I can show you that he used optics, at least for one of his paintings, direct optical evidence that he used. You pose him, pose him, and you tell them, here, this is the scene, you're sitting, you're cheating, the cards are about here. Well, we're very sensitive to where eyes are aimed at. And so we can see if the eyes are off by a little bit, but if there's nobody else in the scene to look at, you can make mistakes like that. Lousy fortune teller? I mean, she's reading the wrinkles in his forehead, maybe. Maybe it's a different kind of fortune telling, and he's, again, looking off into space. So let me go now to change it a little bit. If optics has been used by all of these artists, directly or indirectly, I'm going to show you some other kinds of examples. I'm going to call Monet a highly skilled expert. Let's see how well Monet can paint. And by this time in Impressionism, we're well past photography. Photography has already been declared as as making the painter's job over with. Painters, good painters, are looking for what they can do. How can they represent the world in different kinds of ways than a camera can do that? And Claude Monet, in doing this, painted 9 paintings of the scenes of House of Parliament in London. These paintings are all rather large. They're roughly a meter by a meter, and that plays a key role in this. And he painted them over a period of 2 years. So he kept coming back, and the paintings are most well known for how he represented different qualities of light and fog and sunlight, and just the beautiful ways they've done that. I'm going to show you that I found exactly where he stood when he made these paintings, that I found it optically, and then I'll show you the consequences of that. So this is roughly the scene. So roughly he might have been over here somewhere. Now, and as far as we've been able to determine, the sidewalk 100 years ago was the same sidewalk. It wasn't bombed during the wars or anything, as far as we can determine. And if that's the case, well, it's sort of unlikely he put his easel here. That's a nice place to put an easel. That's a nice place to put an easel. So let's take a camera, let's take a movie camera, and aim it at that region where Monet's paintings are painting that scene, and we'll walk from here to there and see if we can figure out where along this path he might have done the painting. So let's just walk along that path. So I'm aiming my video camera at the Houses of Parliament. It's in real time. You can tell that. There's a jet that's headed toward Heathrow. And parallax causes some light to open up. This tower is closer to us than that tower. Not clear to you in a two-dimensional scene, but 3 dimensions, we have that parallax. And I'll argue that this is where Monet stood. So let's put that back into the scene. And now what I want to do is I'll just trace the outline in magenta, take away the photograph, and then let me lay this, what the high-resolution photograph looked like, let me lay it on top of Monet's paintings. And so what we're going to do is we're going to do this fairly quickly. So there's our outline. And notice how accurately he gets all these features. But notice he always blows that central tower. He makes it too tall and too narrow. Even though all these other features, this is a complicated tower. All those other features he gets. In fact, he always makes that central tower roughly 15% too tall and 15% too narrow. Now, once you could say he screwed up. Twice he screwed up. Not 9 times over the period of several years. So this tells me he did this deliberately. And we can do even more quantitative analysis. This is the place where I claim he stood. There is the central towers. It's late. It's an art audience. I'm not going to do trigonometry for you. You're just going to take my word for it. Or if you don't take my word, those of you who want to sneak out in the back, this is where I would ask you questions if you're sitting closer. So what we know is the angle of view across that scene. This is roughly to scale as well as I can do it. The size of the painting, the size of a human being, that's how far apart those 2 towers were, how far away he is. The angle of view between those 2 towers is 24 degrees. I know how big this painting is, that's 61 centimeters. If he stood back, if he took 1 step back from this painting, which is this big, he sees the same scene, fills the same visual field, the painting, the scene. You can tell yourself, you look at this, that tower is too tall. He saw this in real time, 9 times. So clearly he did it deliberately. So something that optics does is it can give us insights into actually asking questions that you didn't even know you could ask, let alone hope to answer. Why did Monet do this? Dorian, because there's a Dorian here, I'm going to send you, your homework assignment is to visit a Dorian later, and we're going to come to it. There are 2 Dorian paintings, one here in this museum. Big Ben, turns out he stood in the same place that Monet stood. And there's Big Ben. We'll outline it. Oh, I got to say, these buildings didn't exist 100 years ago. They're new. I found a photograph from the time, slightly different position. So we're not going to get this quite right, but that's what the buildings looked like at the time. So this part, we can't expect to get quite right because this is not quite from the right place. Let me put this on top, and we see Derain did the same thing. He makes Big Ben taller. Artists have this tendency, like tall, thin things. So here's stopping where Derain painted his painting, and he makes it more imposing. So here's the one that your homework assignment that's in this museum. St. Paul's Cathedral, and it looks like, I mean, how could you possibly, I mean, it's totally impressionistic. I want to tell you that I've identified where he stood when he painted this optically to, I don't know, I think I claimed a few meters. Looking down, there's St. Paul's. There's a walkway along here, the Millennium Bridge that didn't exist at the time. This region, if I magnify it, what we're going to do is I'm going to start here, and I'm going to walk along with my camera, and I'm going to claim that he painted it standing right there to plus or minus 5 meters. A painting that's highly non-photographic looking. So let's take that. Let's take our camera, aim it at St. Paul's, and just take that walk along there, speed it up a little bit. And we can see certain things. Again, parallax joins these two features. And we can see this is what Derain saw. This is what he painted. And we look here, he's also made this tower about 12% too tall and too narrow. And a couple other examples of painters who did this. Raffaelli's paintings of Notre Dame, there's certain features we can look for. If I drop perpendiculars through the central tower there, it comes right here in the center of this pontoon. Through the center there, it comes right at the edge of this one, and so on. So there's these features we can identify from the painting. Those are going to be our data points. We take Google Earth and look down. There's Notre Dame. There's the bridge we were just looking at. These are where those pontoons are. And our data points, our X is a little bit hard to see here. And I'll draw the lines. That's where he had to stand. Well, let's go there and take a picture. Well, unfortunately, well, it's even worse than this. That you can see, not quite in the right place. What you can't see is right to my left is a great big truck. And so not only are the trees slightly in the way, but I can't go any further to the left. And if I go around to the other side of the truck, I can't shoot through the truck. So I can only get really close, but not quite right, but still pretty good. And we can see he's made these imposing figures, 8% too tall. I should say, when I was doing this research, I stopped in Paris, and I was on my way to give a talk in the United Arab Emirates. And I took all these pictures, and because I'm of baggage requirements, I'm traveling with like $10,000 worth of camera equipment is my digital camera equipment. I wasn't going to do that because I was going to have to check it. And so I took film cameras with me. And I'm worried now, my film, if I go to all this work, and now from Paris I go to the Emirates and back, and if somebody just x-rays them and destroys everything, I'm in big trouble. So I took the film in to be processed every day. I would find these locations, take the photographs, take it in to be processed at a quick 1-hour photograph place that was on the aisle of where Notre Dame is, just so I'd have the developed negatives when I got back. And so I'm going to places where Raffaelli and Derain and Monet, where they had done all their paintings, where they had decided were the most aesthetically pleasing places to paint these scenes. I'm finding those places, I'm taking pictures. Well, the guy, after my second trip back to have things developed, he said in French to me, he said, your photographs, your composition It's excellent. And what can I say? They work. So here we find again, Lebourg makes the tower too tall, 14% too tall. Now Pissarro, we want to talk about it. I put Pissarro in because there's a nice Pissarro upstairs, and I'm going to show you an infrared reflectogram I took of it today. This is just sort of to set the scene. Around 1900, there's some buildings over here I'm going to want you to remember. We're going to come back to later, some spires. But here's a completely different scene by Pissarro. It's the carousel. Notice various heights we've got here that I can notice. The height of the building here, it's lower at this point. That cupola, that turns out is the Pantheon. And if I drop from the corner of that building to the Petit Arc de Triomphe, there are various places, heights. The height of the Louvre at this point is x. The height here is 3.5x. That tells me from the laws of geometrical optics, it tells me relative positions of things. So now, it turns out that the buildings we were looking at were Invalides and Saint-Clotilde. Saint-Clotilde has these two towers that we were looking at. I'll put that back down. Those are where those two towers are. So I draw a line from Invalides through those two towers, and it comes to about here. Now, from the other paintings, completely different scene. We had that corner, the mini Arc de Triomphe, this corner, and so on. From the Pantheon, I mentioned we saw the Pantheon. Draw a line to here. Well, this is funny. They all go to the same place. So let's go there. And from the painting, the distance from here to here, the distance from there to there, that's 3.44x further. The painting is 3.53x further. It agrees for the painting with 2.5% accuracy. So we think of these guys, impressionist painters, as just slopping paint around. They're doing it with extreme accuracy. And if we draw those lines, it comes to that window. And turns out, I'm going to show you, it also comes to this window. It doesn't go to that window. He did some paintings from this window. He did some paintings from that window. And I'll show you that. So to show you that, there's, again, the Pantheon. Oh, let me go back. Go back. Dropping to here, sort of to our right side of the Arc de Triomphe. Here, that's where it was before. It's moved. It's moved over by that far. Here, there are three spires. The one in the middle is Invalides, and the other two are the church. Here, those two spires are joined together. They've moved closer together by 0.14 of a spire distance. Calculations again, it's late in the evening, take my word for it, that the calculated distance between the two viewpoints that I calculated, for some paintings, he was 7.3 meters different than the other painting. The measured spacing between these two windows is 7.4 meters. So I can tell you from an impressionist painting, I can tell you to an accuracy of less than a window where the guy stood. And subsequent to this, my assistant discovered a letter he wrote to his son where he gave his address. Now, and that is the Rue de Rivoli, and I haven't had a chance. I haven't been back to Paris. Actually, I've been back twice. I just haven't had a chance when I've been back to go see if that is the address. But what are the odds it's not? And other calculations we do. Let me just get rid of this. So there's a tower. We have the angle between these two positions is 29 degrees. That tells us that if he'd used a 35 millimeter focal length lens, to put this in context that maybe you would understand, he would have used sort of a little bit toward the telephoto lens viewpoint of this. I'm not saying he used a lens, and I'd be very surprised if he actually did use a lens. I'm saying that what he decided to capture for us was the equivalent of a scene as seen through somewhat of a telephoto viewpoint of the world. That's sort of he's capturing a narrower angle of the world for us, as opposed to this scene from that water fountain. Nice thing about working in these old European cities is nothing ever changes. That you can go back 150 years later and find things exactly as they were before. And that angle of view between those scenes is 35 degrees, which tells us for the whole painting, it's equivalent to a fairly wide-angle lens. So from the same viewpoint, the man is giving us wide-angle views of the world and telephoto views of the world. This is a painting that's upstairs. It's Pizarro painted 1898. One of the things I've done, I've developed an infrared camera for doing infrared reflectography, and I've got a publication coming out on this. And I've been carrying it around the world, taking infrared reflectograms to see what we can see. And I'm going to show you something about this painting that afterwards, your homework assignment is to go see it for yourself. And you only have to go up one flight of stairs to do this. So I'm going to fade in the infrared reflectogram. I took this photograph with a visual camera, and we'll fade in the infrared reflectogram. And the thing we see, remember, infrared, certain pigments are much more transparent to infrared than others. And one thing we notice about this, what is all this black stuff? Here, here, and there, and also here. So let me magnify this little region for you. So these black square regions, and one that of all the things I want you to pay attention to when I fade into the visible, you're going to have to focus on something. Notice that here we've got this like brush strokes there, but that's all we've got is like daub, 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 daub. Now let me fill in. There's black other places. There's black everywhere else. He's used a very small amount of a different pigment for whatever reason. So there's some green in here. But of the entire painting, what the infrared tells us is that maybe ran out, who knows why. Let me go back now, a couple steps. These little black regions, that's going to turn out to be a little green thing you put in the, why put one little green dot there, one little dot of green here, and then these black. Look for these features. You can't see them they're not obvious in the visible, except now you can look for them, that they stand out very differently. Of all the pigments all over, why did he do this in these places? So to summarize, I haven't shown you, take my word, go to art-optics.com, and you can download the papers, read them for yourself. The overwhelming evidence that as early as around 1425, 200 years earlier than anyone ever thought was even possible, let alone was done, name brand artists, the Van Eycks, the Bellinis, the Caravaggios, were using optical projections to aid them in making portions of their paintings. And it does fundamentally affect our understanding of the evolution of art over the last 600 years. That the photographic look that suddenly comes in, this post-medieval photographic look, is an artifact of optical projections. It's not natural to human vision. So when you look back in time and you look at a painting made in 1700, optics is involved, either directly or indirectly through the mind of the artist. And that not realizing that optics was used prior to 1600 has resulted in us making implicit assumptions that are implicit assumptions that are wrong about how paintings and photographs replicate our visual world. Only the last 600 years has our visual cortex been looking at images. So our evolution over 60 million years or so has given us ways of looking at images that are quite different than the way that we're representing images now. But exposure to television and movies and countless photographs has given us the misunderstanding that photographs do represent reality, and has given us a reasonably good training in how to interpret photographic results. And the consequences of this really does have far-reaching implications, both for understanding post-1425 art as well as our post-photographic world, where now it's perfectly common to see things, very easy to make composites. So it is a paradigm shift in the way we see art. So thank you. Now, I'd be happy to answer questions. Yes?
I was wondering, why didn't they own up to this? And what does it matter?
Why didn't they own up to it? Well, so it's not clear they didn't own up to it. So one of the two earliest painters I can show you that used optics are Robert Campin and Jan van Eyck. These two are documented to have known each other. They lived 15 miles, a day's horse ride apart. The next three artists that I can have scientific evidence that used optics are Petrus Christus, Hans Memling, and Rogier van der Weyden. These three were apprentices of those two. The first painter outside of Flanders that I can show you used optics was a Spaniard whose name was Juan de Flandres, Juan of Flanders. So they certainly were telling each other, they were talking to each other and conveying the knowledge, but there's no writings by Van Eyck on any subject whatsoever, I mean, that have survived the 600 years. The paintings are the documentation. If you read the paintings, if you read the images, and it's really a question of visual literacy, that you have to be literate in the reading of images. If you do, it just hits you in the face that they used optics. Yes, in the back. Yeah. So I can tell you that there is no overlap. That if you use a grid, or another way of doing this is you have a fixed eyepiece mounted on a post with a grid in front, and so I can only put my eye here, and I count over like 12 squares to the left and 2 squares up. There's your head, and I paint on my canvas 12 squares over. Like that's identical geometrically to optical look. So it replicates exactly as if I'd taken a photograph of this. Where I can show you optics was used is where mistakes were made, where somebody has refocused, which has changed the magnification, or they've moved their lens and accidentally pieced together something in segments. So what Dürer draws is, if you followed his prescription exactly, none of the mistakes we show would evolve. Yes? Yes.
Is there any evidence extrapolated as to how they would kind of pin in the image, or that they were painting at any time upside down in gravity, that kind of thing?
Okay, so evidence from gravity and the like. In fact, you don't really need to work with the image upside down very much at all. That it's very unlikely you would paint upside down. I mean, you could if you wanted to. It's just easier to paint right side up and the like. Where the most likely scenario that we postulate that would use is your image is projected upside down. I capture the features of you, corners of your glasses, your tie, and I just, with a pencil, just grab those points. Well, from that point, I've got the optical perspective built in. Might as well just turn it over and in bright daylight paint everything in just as was normal. So the painting likely would have been done just mixing colors, doing stuff. It's just easier to do it right side up. But I should say also that, to the best of my knowledge, no one's ever really looked for, like, if the paint had run this direction vertically. People just haven't looked for things like that. But even there, the whole painting would have had to have been done sort of like that. Because if you painted for 15 minutes upside down. Then you turn it over and you start working everything in. Any evidence that paint had run one direction is going to be completely obliterated by the subsequent hours of brush strokes.
Except with your camera.
What do you?
The infrared.
Well, the infrared, no, I'm saying it would be obliterated because the brush strokes that were done upside down are going to be smeared over by right side up ones. Yes?
Are you suggesting that a lot of these painters were in some sense deluding themselves as to what their visual perception of the world was, and that they were actually seeing things other than as we now believe they were, or that or isn't it possible that they looked at things in a certain way using certain devices and thought, well, this is going to be what I call a painting. It may not be identical with what we experience when we walk around and see things, but this is the stuff I'm going to put on canvas. Maybe they were aware of these things. How is this significant, what you're talking about?
No, so what I'm saying, like in the case of Monet, those 9 paintings, I'm saying for sure he saw that he made the tower too narrow and too tall. He did that on purpose. That wasn't, he could tell that it was not a photographically accurate representation of reality, but perhaps to him, I mean, the tower does look better, tall. I've been doing this experiment. I photoshopped in a accurate tower and a tower that's taller and narrower. I've been doing an unscientific survey of showing people, which is Parliament. And more people pick the taller, narrower one as the more aesthetically pleasing, clearly, is Parliament. So Monet knew that, I would say. I would speculate that he knew that, and it just looks better than the architect made it. And so he made it to look like he thought it should have been made. So he wasn't deluding himself. He was giving his version of what he thought that scene should be. Does that answer your question?
Yeah, I guess I'm just trying to grasp the significance of the distinction that your thesis, that, historically we thought, we didn't understand the importance of optics. We didn't do production of these paintings. Is that what you're saying?
Yes, once you know optics was used, you look for different kinds of evidence. You look for effects of how it's affected the vision of the artist, either directly or indirectly.
How would you look at somebody like the Mannerists who, look at paintings where there was deliberate exaggeration?
So this is not a theory that explains all paintings of all time. So I'm not trying to say that whatsoever. And so a good artist who maybe even recognizes, this sort of optical look to it, I don't want that. I want something that deliberately is not optical and is trying hard to convey something very differently. There's a whole variety of things in art, a whole variety of schools, a variety of approaches to it. But what I am saying is, though, that once you realize that there is scientific evidence that Van Eyck, Campin, Bellini, Caravaggio, Ingres, Vermeer did use optical projections, that changes things. That changes the world of how you look at how paintings were created. Yes?
What was the quality of lenses at that time? You're taking your camera now, which is an extremely sophisticated piece of optics, and the focal length
Yeah.
and curvatures of the lenses are all calculated and machined by computers. And now you got these people many hundreds of years ago who are doing this by hand.
Right.
And I'm kind of curious as to just how relevant your lens images would be to these images that were made by lenses that long ago. Like, for example, I don't know if Galileo's original telescope still exists.
It does.
Okay.
It's actually in the U.S. right now,
Okay.
on tour.
To look at that lens and just
Yeah.
see how good of a lens that really is and compare it to, that would give you some idea of how good the lens making was at least at that time.
Right. Okay, so we've done all those things. And so just in the interest of, 50-minute talk, I left out, I could lecture to you for a full day and not even scratch the surface of the information we've collected. But one of the things we've done is, what I said, and I didn't even talk about it much more after that, is that we have lots of circumstantial evidence that mirrors were used, not refractive lenses. So I make a metal mirror out of brass or iron. I made them and aluminum. I grind a concave metal mirror, which projects a spectacular image. In an hour, I can grind a concave mirror, which is grinding paste, that projects an image that has a resolution that is 3 times better than Van Eyck needed for any of his paintings. They project images that they're not as good as modern. I mean, their lack of not being good like a modern lens, in fact, has advantages. That some of the light that would have been in the highlight gets scattered into the shadows. The problem a painter has is the blackest black they have is 5% reflective. The brightest white, brightest yellow, going to do the sun. What's 95% reflective? That they've got to compress the visual scene from 5% to 95% to do that. So to the extent that the lens helps solve some of those problems by taking some of the light and putting it in the shadows, actually helps them. But we've made lenses. I've used, I'm going to show this at the NAEA videos. I had a couple art education interns who have reproduced 3 paintings so far of exactly how they're done with lenses we ground ourselves. The other thing is I showed you Van Eyck, one of his paintings, somebody's holding a pair of spectacles. I've done the experiment where I've taken cheap drugstore spectacles and I deliberately scratch them up with sandpaper. Look at them, see if I can still read, scratch them some more, still read, and I project an image. At the point where they're no more useful for reading, they're also no more useful for projecting an image. So the fact that people are holding spectacles and buying spectacles tells me that they had to be good enough to project images of good enough quality for this. Yes?
Actually, you were talking about the art education end of this. One of the things that I found fascinating, I've done some reading on your investigations with David Hockney, is how exciting this actually is trigonometry. I mean, I taught myself that subject and I had taught it for many years, and it's really dull as ditch water. But this is some very, very, very sexy applications.
Yeah.
Figuring out where an artist was standing when they made an image. Do you know if there's been any feedback from your findings into mathematics education, particularly teaching trig?
Well, so ironically, last month in New Orleans, I gave an invited talk at the National Science Teachers Association. And these things take time to enter into the curricula. And there are a lot of science teachers who are very interested in this, because anything that you show somebody, I would argue, and again, another experiment you can't really do, you take a Van Eyck painting, you take it to some place in the world that nobody's ever seen any painting ever in their life, and you say to them in their language, is this pretty or not? They'd say, yeah, that's pretty, I think. And so kids who might not naturally want to learn mathematics or anything, you say, well, if you learn tangent of theta, you're going to learn something about how this painting was made. It's a way to suck kids in. Some set of kids that wouldn't be sucked in otherwise.
Yeah. My experience with geometry was I was an artist first, and I took geometry as perfect circles. That's what got me. Perfect circles, I can make triangles that are guaranteed, and the tie-in with logic is just fascinating, where you can actually establish that if you follow the procedure, you can depend on the results. And that's, I think about things like, say, building stage flats. You could be guaranteed that if you build it this way, it will not fall over on the actors.
Yeah.
Particularly if you're one of the actors, that's a very reassuring finding. So,
But of course, we scientists knew this all along.
yeah,
And
it's a division, it's very artificial division when you're teaching, say, at high school level between the science curriculum and the art curriculum. And
I have no idea the art curriculum in high school. I never took an art class. All I've ever done was I like science classes. So here I am talking to art educators, and life is pretty funny. Getting master's classes in watercolor from David Hockney, and I've never had a art class. Yeah.
Why would artists have wanted to even use optics? I mean, especially some of the examples you showed here, some of the Monet, the Parliament and so on. I mean, he obviously wasn't trying to capture, was it Monet?
Well, yeah, but I would say he wasn't basing those on projections. So I may have, if I confused you if I gave you that impression. No, I'm saying Monet did get all that accuracy, but he was not, I have no reason to suspect he used optics. He did that just from brain power and the indirect use of optics, of knowing what an optical look was.
But the ones that did, I mean,
So let's take somebody like Van Eyck. So Van Eyck was one of the richest people in Bruges, in Belgium, in 1425. He projects an image, he captures some rich person's objects, and that rich person then tells all the other people, hey, you should go to Van Eyck for your portraits, because he does stuff that nobody else can do. Yeah, and if people like that, which apparently they did, it instantly sort of becomes a thing to own. And so that's how you become wealthy, and that's why the style takes over. Crass commercial reasons. Other questions? Your 2 homework assignments are what? The Durain, wait a minute, and the Pizarro, okay? Yes, question.
Within your own perspective of art from the time where you began doing this till now, I'm assuming it has enriched your perspective and appreciation of art exponentially?
That's a big number, but yeah, a lot. Yeah, sure. Yeah, knowing how these guys were operating. Okay, so I've never taken an art class or an art history class. However, my entire life, starting from age 10 or something, I had a good mother, I guess. I've gone to art museums of my own free will. So my assistant wrote her master's thesis about David Hockney and me, and made me dredge up all sorts of information. And so one of the things that I was able to figure out for her is by age 30, I'd been to more than 25 museums in, I forget how many countries, half a dozen countries. These are, because I travel as a scientist, and as a scientist I got some free time, I go to the Louvre and I look at paintings, and I enjoy this. Now, there's a performance artist, Chris Burden, who's best known for a piece called Shoot. He had himself shot in the arm in the early 70s. Anybody familiar with that? Anyway, what? Yeah, that was the piece. He had himself shot in the arm. It's called Shoot. You can find this on YouTube. And it became a very well-known in conceptual art. I was in one of his pieces and aided him in 3 others in the early 70s when I was in graduate school. So I've been interested in art my entire life, and self-trained, if you will. And there's been an advantage to that, because what we're talking about goes against really the canon of conventional art history. And a lot of art historians have been very angry with the kinds of things that we've said. But having not had that understanding that I would have had I been trained in art history, led me to look at it just with fresh eyes. Either something's the case or something's not the case. Either I can calculate something from trigonometry or I can't calculate it. Science really is black and white. Science is an aggressive discipline because we don't say, yeah, maybe this, maybe that. It's just, it either is or it isn't, or we don't have enough data yet to say either way. And so my approach to it was the fact that I was self-trained in this. And I think made discoveries because of that. Yeah.
I have a technical question. I've had some training in like the very rigid classical French academic realistic drawing, where you basically, just as you were doing in your pictures, you establish a viewpoint, close one eye, you do all
Yeah.
these super precise measurements. Have they done, I'm assuming somebody's done some kind of study about if you draw something that, and you're highly trained, how accurate are you, say, compared to a computer view, or camera view of the same? I'm assuming people get real when they get skilled at that. They can do.
I don't know how, I don't know if somebody's ever tried to quantify that, but again, if you did that and you were very, very skilled, the more skilled you are, the closer you come to being just what a camera would give you.
Yeah, that's
So,
one of the things I didn't like about that is you get this very flat work that looks, because it is monocular when you close one eye.
well, there's a Bouguereau upstairs as your third homework. That's for extra credit. There's a Bouguereau to look at, and write an essay on why you don't like the way it looks. Well, thank you for your attention. Go back to the rock and roll.